Hi, I'm Steve Ward and I'm a pre-sales consultant at Emerson. In this presentation, I'm going to take you through a technical overview of our PACEdge industrial Internet of Things solution based on a combination of our industrial PC hardware along with a range of open source and proprietary software. First, a safety moment. Emerson encourages safety both at a corporate level but also for individuals. In order to stay safe, you can review your working environment for issues such as various hazards around tripping and slipping, lifting, electrical issues, desk and computer ergonomics, driving safely, wearing appropriate personal protective equipment, safe working at height, ladder safety and fire safety. If you feel that it's unsafe, you're encouraged to stop work and report the issues and including near issues and make sure that you can make it safe, either by whatever actions you need to take or by having responsible people take those actions. And we encourage you to undertake and manage these 12 life-saving behaviours to make sure that you can stay safe. Emerson offers a complete line of control solutions, allowing your customers to scale from single machine solutions up to a complex full plant enterprise environment. In this slide deck, we're going to be focusing on Edge and the industrial Internet of Things and analytics, and there is an overlap here with industrial PCs and with HMI SCADA software. So I encourage you also to take a look at the Movicon slide deck and the industrial PC slide deck we have. But this will be focusing particularly on PACEdge, which is a combination of industrial PCs and the open source software, and also with the option of using some of the Movicon components. In a wider system, you might also be using switches to interface with higher level and lower level systems, and you may also be using power supplies for your I/O power, and you might also be using I/O itself in order to actually read information from the physical sensors and actuators that are on the plant. But the key focus will be on the PACEdge components themselves. We'll start by defining what is the edge. Edge is an information technology or IT-centric term that refers to the edge of the corporate network. So in the center of the corporate network, you've got your main servers and key applications that are used to run the enterprise. And as you move further away from the center, you move towards more distributed applications until you reach the edge, which is where all the devices and machines are located. So this might be devices or machines in your manufacturing location, or it might be devices or machines which are remote from your corporate center. For example, if you're a water company, you might have pumping stations and you might have things like water treatment plants, and they would be at the edge of your corporate network and far away from that corporate data center. Now, the opposite of IT is OT. OT means operational technology, and that's the people who are more concerned with operating the plant. So they probably don't refer to this as the edge. So the edge does come from the IT people rather than the OT people. And that's why we also refer to edge devices and the Internet of Things or the industrial Internet of Things. So there is a variety of different edge devices. You can have an IoT gateway, which transfers data from the edge machine or process to the data center. You can have an I/O computer that performs that same data transfer function, but also performs more local data processing. And that can also be used to provide data to the operator and to other interested people. And then within Emerson, we also have the concept of an edge controller, which combines all of the IoT computing and gateway type functionality with a PLC CPU into a single box. And the purpose of the edge is for continuous improvement and digital transformation. The idea is that as you have more and more data about your operations, you can get a better and deeper understanding, and that can help you make decisions to perform improvements. And then of course, once that improvement is performed, you then have additional information afterwards to be able to see, did that improvement really work? And if not, is there something else you can do? And also, if it did work, how can you keep on track to maintain those improvements? So it's all about continuous improvement, digital transformation. Some people call that DX. And it comes down to effectively minimizing unplanned downtime and improving quality and improving efficiency. Now, we also come across terms like analytics. Analytics is another word for an algorithm that's used to monitor or control the operation of a machine or process. So a simple example might be monitoring machine runtime or start-stop cycles to determine when routine maintenance is due. And the reason for doing this is that many machines are maintained on a timed basis. So you might maintain the machine every 6 months, whether it needs it or not. But if you're using the machine a lot of the time, it may be you need to maintain it more than every 6 months. Or maybe if it's not used all the time, maybe 6 months is too often. So by moving to a cycle time or a runtime approach, you can then perform maintenance on a more effective pattern when the maintenance is actually required, rather than just performing it when it needs it. So that can improve machine operations, again, reducing unplanned downtime, but also minimizing excess maintenance. Another thing you might want to do is monitor machine usage and output to determine overall equipment effectiveness, or OEE. So OEE is a measure that combines availability of the machine, it combines the performance of the machine, and it combines the quality of a machine into a simple measure, and then you can drill down within that measure to determine what the underlying factors are. So the key point there is that as you make improvements to the machine, you can focus on the parts which have the most effect on overall equipment effectiveness, and then you can also monitor the improvements in overall equipment effectiveness to see that they are effective and to keep them on track for future operation of the machine or process. There might also be collecting key performance indicators to provide a simple dashboard to the users. So that might be energy usage, it might be simple data that's important to that machine and to those operators. But these are very simple examples of simple analytics used to monitor and control the operation of a machine or process. There are more advanced examples. For example, you may have a digital twin. With a digital twin, this could be implemented as a data-driven model or a physics model. So the idea here is that you have a model of the plant or process, and as the plant or process is operating in real time, you can compare that with the digital twin to see if there are any differences or anomalies. So it might be your digital twin is operating differently to your actual machine, and that could indicate that your machine has degraded operation. Maybe there's tool wear, maybe there's something that's causing issues, maybe there's a raw material difference. But the idea of a digital twin, this gives you a very good, accurate model of how the machine or process should be operating and allow you to compare that against how it actually is operating. What you can also do is collect larger amounts of data to allow comparison of different machines and even across different plants to determine what their capabilities are and to share best practices. This can also be used across different shifts as well. So for example, you might have 5 different machines. One of the reasons for collecting data about those 5 different machines might be to determine which one is the best machine for certain applications, which one is the worst. So you might decide that one machine is better for your highest paying high quality customers because it has the highest quality output, but it might also be the most expensive machine to operate. So for less demanding customers or ones that want maybe a quicker turnaround, you might use a different machine. That same information could also be used to determine, is a machine at the end of life and does it need maintaining or does it need updating, or maybe even you don't need that machine at all. We can also do machine learning. Machine learning is an advanced control model to make sure that the machine or process is always operating at its most effective level. And that can include things like advanced PID control to make sure that the system is operating within its required parameters. But generally with this, we're going beyond what you would normally do with PID into a much more advanced machine learning model. So that used to be called things like fuzzy logic, could also be called adaptive control. And it's an aspect of machine learning to perform advanced control, and that could go all the way up to advanced process control, which is in the realms of some high-level software which can be used to optimize entire plants according to different operating conditions. So these are all examples of analytics. They go from very simple all the way up to very complex. Not all of these might be applied at the edge. For example, a digital twin or advanced process control, they might be more computer-oriented applications. But some of these simpler models, you might run them locally. And also, if you've got large amounts of data that you want to collect, that could be worthwhile running at the edge and running the analytics at the edge, because you might need that high-speed throughput, you might need high-speed response, and you get that by running at the edge rather than running at the data center or in the cloud. Another reason also is data costs. If you have a lot of data to transmit, then that needs a lot of bandwidth, and that can be quite expensive. So another reason for having local analytics is that you're able to reduce that amount of data and reduce your data transmission costs. So just to correctly define IT versus OT, IT is information technology, or sometimes known as information systems, but I think we've reverted back to calling it IT these days. IT is generally concerned with high-level applications and day-to-day business operations. So that can include the networks and the computer hardware. So that can include servers, desktops, laptops, and so on. It can include storage, cybersecurity, and then at an operational level, that would include all the systems you use to manage and run your plant or your machines or your business. So that could include HR systems, finance systems. And from a manufacturing point of view, you might have manufacturing execution systems and you might have enterprise resource planning systems. So all of these are normally the concern of IT. Traditionally, these have a low speed response. It can be as low as a few seconds. For example, email is something that you would expect to send an email and have it received quite quickly. But in some cases, things like ERP might produce a weekly schedule, and then that might be translated into a daily schedule by an MES. So that's a much lower speed response that could be in the order of days rather than a few seconds. Operational technology is very different. This is normally concerned with your manufacturing operations. So these are your cells containing your machines, which in turn contain the PLCs, the motion control, the operator interfaces, the HMI SCADA. This could also include robots and CNCs, and it might include the operators themselves who are actually performing operations on these machines. Typically with these you need a much higher response. It's often milliseconds, so if you're controlling a high-speed machine you might want a millisecond or 2 millisecond response. And if you're looking at operator responses, they might be a bit slower, but it's normally much faster than what the traditional IT response time is. So operational technology, or OT, this is all about the actual control equipment. And today there's a bigger and bigger overlap between these different types of technology as the underlying technology converges. And also because business and user requirements often now concern multiple departments. So people in the IT team might be concerned with cybersecurity in the OT equipment. People who are operating OT equipment might be concerned with the interface to the MES operated by the IT people. And they might all be concerned with the underlying networks and computers and the user management and so on. So there's often a big overlap between IT and OT, but generally we do separate them according to these criteria here. So this is where we can start to talk about PACEdge, and we can also compare it with Movicon HMI SCADA, and we can see how they have differences. So Movicon, I've got a separate slide deck on that, worth looking at. Movicon covers human-machine interfaces and supervisory control and data acquisition, and this normally has an OT focus, whereas PACEdge is normally concerned with the Internet of Things, and because PACEdge is running at the edge, it's normally a concern of IT people. Again, there is an overlap. Sometimes IT people might want to be concerned with Movicon, sometimes OT people might be concerned with PACEdge, but really they are different solutions that can do similar things but in different ways. So with Movicon, this is software that can be combined with Emerson hardware. There's a nice low-cost entry level with small solutions, but it's very much focused on data collection and then best-in-class graphics capabilities to be able to do visualization. So Movicon is based on latest technology. We have a lot of competitors that are using legacy frameworks, but with our latest technology, although it's an OT focus, we are leveraging IT technologies to have secure, high performance and future-proofed applications. And Movicon is also very open than a lot of our competitor equivalents. Yeah, we use open source protocols, and we've got multiple protocols, proprietary protocols, to talk to many different devices. Now, PACEdge has some of these same functions, but again, it's more of an IT focus. And for PACEdge, because people are generally looking for solutions rather than a combination of products and software, what we've done is we've taken a combined hardware and software approach for industrial Internet of Things applications. So the reason for doing this is we can offer a complete solution. A lot of our competitors generally only offer the hardware and leave the software to the system integrator or the OEM, or some of them offer a cloud-based solution but no hardware to allow you to actually interface to that cloud-based solution. So PACEdge gives us a lot more than our competitors' equivalents, and it's also open in the same way that Movicon is. We use a combination of open source software, and we support multiple protocols as well as open protocols. We also support proprietary PLC type protocols. And what we have with PACEdge, because it's a complete solution on a single device, this means that you can get very good cybersecurity and updates provided by us, the vendor. And also, because we're experts in providing industrialized hardware, we offer very compact and rugged hardware, especially at the high end, where we have very high and low temperature support. We have very good ruggedness in terms of shock and vibration, and we also have very good performance, but in a compact footprint that can fit easily inside a machine or a panel or at the edge device, be that whatever it is. So the Edge offers many potential benefits for OEMs and end users. Call it continuous improvement, call it digital transformation, call it Industry 4.0, whatever you want to call it. Can also even link into lean manufacturing and Six Sigma. But ultimately you need data, and this is where the Edge can help. But as well as talking about the data collection and the underlying hardware and software, we need to think about, what is the idea of doing this? What are the improvements we can obtain, and how can we think about calculating return on investment? So it boils down to generally improving maintenance and improving efficiency and reducing waste. So for example, one thing we can do is evaluate breakdowns, and we can eliminate common issues, maybe using a Pareto analysis. So you can look at the ones that occur the most time or the most frequent or that cost the most, eliminate those, and that can help improve the efficiency of the machine and reduce costs. If you're an OEM, you might want to ensure the machine is used as intended. Maybe you sold the machine to be intended for use as 8 hours a day, 5 days a week, but using an edge device on the machine, you might record its runtime, and you might find out it's being used for 10 hours a day, 7 days a week, and that's causing the machine to fail early. So what you can do there is you can use that in your negotiation with the end user to say, look, you weren't using the machine as we originally sold it, and that's why it's not working as intended. So that can reduce spurious warranty claims. You might use the machine performance to feed back to your development team to optimize future products. So again, you can answer questions like, how is the machine actually used? If you sold it for 8 hours a day, 5 days a week, but most customers are using it for 10 hours a day, 6 or 7 days a week, maybe you need to redesign your machine or redesign your terms and conditions so the machine actually can be used for how it is being used rather than what you designed it for. Maybe you can find out if there are quality issues. Are there things that break down particularly often? Maybe you could change your vendor of a particular component to make the system more reliable or improve quality. Can you reduce costs without affecting performance? Maybe the machine is over-engineered and you could use cheaper components to maintain performance but reduce your costs and increase your profitability. Conversely, you could do it the other way. Can you improve performance at no extra cost as well? One thing that we see a lot of OEMs doing is moving to different revenue models. For example, rather than sell a machine outright, you might have an arrangement where the end user pays per machine or rents a machine. There may be vendor managed inventory. You may be selling something as a service rather than a product. And you could even charge based on end user value. So for example, knowing how much you're actually producing and saving the end user, knowing that might be that you charge the customer based on that rather than, again, just that straight up upfront machine cost. For end users, you might want to compare machines together. You might be using the correct machine for specific tasks. You might decide which machine to scrap or update or replace. And again, based on the machine's throughput, based on its quality, you can assign those particular machines to particular customer orders. You can compare plants and processes, sharing best practices, maybe even encouraging competition between teams, and even simply monitoring teams can result in improvements in some cases. You might want to compare raw materials. What affects yield or quality or scrap? You might be saving money on a cheaper raw material, but if that's causing more scrap, then you might be having a false economy there. So by understanding what your raw material is and how that affects yield or quality or scrap, you can make those decisions and see where you're saving or wasting money. You can also get a better understanding of the process. It might be that you think you know the process, but when you actually control the process, particularly after several years of operation, you might find that there are previously unknown external influences and effects that you weren't aware of. Remote monitoring is a common application, and this is one of the easy ones to justify. Rather than have people on site, if you can monitor the machine remotely, you can respond to breakdowns. Obviously, you want to respond to them quickly as possible, so having immediate notification of a machine broke down is very useful, but also knowing what went wrong with the machine. Being able to arrive with the correct parts and tools, and maybe even with the correct engineer with the correct knowledge. All of that is very important in monitoring the machine, but getting back into operation as quickly as possible. You might want to track machine use. Again, for maintenance, rather than using time-based maintenance, you might want to move to condition-based maintenance. Maybe that's based on runtime, maybe it's based on machine speed, maybe it's based on the amount of widgets it's made. So there are lots of things where you can move to a condition or process type maintenance operations rather than just fixing your machine every few months. You might want to monitor energy usage. Maybe you manage startups and peak loads. The idea here is that you can look at your energy usage and say, right, I've got a big peak here. For many energy utilities, they charge based on your peak demand. So if you can stagger startups, or maybe you can reduce those peak loads, you might be able to reduce your energy tariff. Alternatively, it could be that with energy usage, you have particular usage patterns through the day, so you might want to flatten that. It could even be you want to increase your energy usage, particularly when energy is cheap. Maybe there are times of day when energy is lower cost, so you might want to optimize your processes to use more energy at those times. That helps balance the grid, so it helps your energy supplier, but of course it also can improve your capability, or it could be used to reduce your energy bills. If you have fleets of assets, you might want to coordinate fleet activities. Maybe use the best assets first, maybe compare different operating modes. So for example, if you've got a fleet of, say, generators, you might say that certain generators are more efficient than others, and you might want to use those ones first rather than use the inefficient ones. But when you need a peak load, you might have to use all of them. But then again, there may be offsets there. If you've got a fleet of 100 devices, do you use all 100 running at 75% if you only need 75% of the full load? Or do you say actually it's more cost effective to only run 75% of them at 100% operation capabilities? So again, by knowing things about fuel usage, knowing things about scrap and utilization, and knowing about maintenance costs, that can help you optimize those fleets of assets. You can also collect data to ensure compliance with safety and environmental regulations. It might be that if you're, for example, dumping effluent into a river, you might have to ensure that the effluent is of a high enough quality so that you don't have to pay a mandatory fine to the environmental regulators. So again, collecting data becomes very important to reduce those costs. And then whenever you're doing any sort of continuous improvement approach, you're probably looking at lean, you might be looking at Six Sigma, you might have operational excellence, call it whatever you will, but ultimately in order to be able to take decisions and perform improvements, you need that data. For example, when I was doing Six Sigma projects, we used the DMAIC process, so that was define, measure, analyze, improve and control. And certainly you need data at the define level, because otherwise how do you know what the problem is? But then you go into the measurement phase and you definitely need data there. Then you do your improvement. But then you also need data later on in the control phase to make sure that your changes you made actually continue to have an effect. So Six Sigma, very reliant on data, so is Lean, and so are many of these other continuous improvement and operational excellence and other manufacturing approaches. And finally, having data, this can help you optimize startups and changeovers. I've seen this before on large assets. You might want to optimize the startup by starting it up as quick as possible, but it could be that by using that accelerated startup mode, you're actually causing a requirement for more maintenance and resulting actually in more downtime. So it might be that by knowing more about the startup and following the approved processes, you might actually be reducing maintenance and saving costs overall. And the same with changeovers. Is it better to have a long run of the same product? Is it better to have shorter runs of different products? And that can be affected by the ease and simplicity of the actual changeover processes itself versus the other maintenance costs, and also that can relate into costing information with whatever it is you're selling and making, and also quality information. Again, it could be that changeovers are associated with scrap, particularly as you start the machine up. There might be scrap to begin with, and then as you close it down. So again, there might be various optimizations you can make there to have improved startups and changeovers to reduce costs in whatever way you need to do it. So lots of potential benefits by gathering data, and the way we gather data is by implementing these edge and IoT technologies. We'll now take a more detailed look at edge and industrial Internet of Things using our PACEdge solution. Now, PACEdge is a combination of technologies. What we do with PACEdge is we combine a rugged industrial PC, we have a Linux operating system on top of which we run Docker containers. Within the Docker containers, we run a variety of open source software for different applications. You've also got the option of using Movicon software as well. And within this, we also add in cybersecurity protections. And all of this is amalgamated into a single device to solve edge and industrial Internet of Things problems. Now, the easiest way to think of capabilities of PACEdge is to divide the sorts of applications we come across into three main areas. And there's an overlap between the edge controller and the other two. But the two main aspects we see are for an edge gateway. And with an edge gateway, what this is a device that sits alongside your PLC that's performing the machine control, and it gathers data and sends it up to the enterprise layer. So that could be an on-prem database or a cloud-based database. But the idea is we're collecting relevant production data and putting it into another application, typically a database application, from where that data can be analyzed. And once the data is in that database, it can be analyzed in multiple ways, but the key part is collecting that data to begin with. Now, the reason for using an edge gateway, this is a relatively low cost device, relatively simple in terms of performing the data collection, and it's also not interfering with the PLC operations because it's a separate device. You might have a HMI SCADA that could do this, but then you're potentially loading up the HMI SCADA with more data. You might be able to get the data directly from the PLC, but again, you're potentially loading up the PLC with more workload. So adding on a separate edge gateway is a nice way of separating your real-time PLC control from your edge functionality that you need. So the edge gateway is normally concerned only with data collection. It collects data and it forwards it to your enterprise layer. There may be some pre-processing of data. There may be some simple calculations. One thing you might also do is if the machine layer is a long way away from the enterprise layer, that might also be doing a store and forward capability. In case the database or the network is down, you might want to avoid loss of data by using the edge gateway for that store and forward as well. But generally, it's a relatively simple device that's collecting data and then forwarding it to the enterprise layer. So the middle one here is where we have a more powerful computer, and now we do edge computing. So the idea now is we're still doing that data collection, but now what we might also be doing is some more local calculations to analyze that data, and potentially we are writing that data back to the machine to control the machine or process. So this now is a two-way process, and we're doing more of these analytical type functions. So for example, if you're running a digital twin and you see that your process is drifting away from ideal operating parameters, then what the edge computer might do is, as part of the digital twin it's running, it might tweak the set points in the PLC to bring the process back into control, or to minimize any sudden downtime events or any unexpected operation of the plant or machinery. So we're doing more complex control here, and this is why we need the edge computer. It needs to be close to the PLC because we want to make sure that we're operating within time, and there might be an awful lot of data there. So sending that up into the cloud and then having it processed in the cloud and sending it back, yeah, you might have a very long latency there. So with the edge computer, we can reduce that latency, and we can also reduce the amount of data that needs to be sent and performed and collected across the different layers. And then at Emerson, we have a potentially unique solution here. We have the edge controller, and what this does is it combines the logic part of the process, so it's a PLC CPU, and it combines the edge gateway or edge computing functionality all in a single box. So the benefit of doing this is that you have fewer components to buy, you get better cyber security, you get even lower latency between the devices, and it makes the solution much more straightforward and easier to implement and more seamless because everything's in that single box. You can also get practical benefits as well, such as reduced panel space. You're not driving as many devices, so your power supply capability is reduced. And it's just a much nicer, neater solution compared to having multiple devices. And there could also be benefits in terms of a single source of supply, a single source of technical support, and full integration of all of your different applications. So the edge controller combines both the PLC CPU with the PACEdge stack, which I'll come on to in a minute, and that allows you to have all of that in a single box for better cybersecurity and better performance. So what sets PACEdge aside from other competitor solutions is this combination of the industrial PC hardware and also a set of chosen software that Emerson has selected based on best of breed capabilities, along with our Movicon software. Now, this is all pre-installed. The connects to web HMI options are separate or optionally installed or purchased depending on which the hardware platform is. But by default, you get all of these other software components, and these are based on open source packages. But it's much more than just a set of packages that we've pre-installed. We've also added some additional functions as well, and I'll cover that in a bit more detail later. But the key point is we have application management based on a Linux operating system. So Linux gives you very good security, but also works really well in terms of performance because you haven't got the overhead of all of the Windows applications, and particularly the graphical user interface. Having said that, you can use the graphical user interface if you want to, either using a local plugged-in monitor and keyboard and mouse, or possibly via some sort of remote support type interface. Anyway, we've got the Linux operating system to host the applications, but rather than just run the applications directly on the Linux operating system, we use Docker for containerization. And the reason for using Docker with containerization is that it means that you get very good security and isolation between the different projects and applications here. But it means that you're not using up too many additional computer resources. So if you think of things like virtualization, virtualization allows you to have multiple operating systems and multiple independent packages running on the operating systems. But it requires a lot of computer resources because each operating system runs alongside other operating systems. The benefit of using Docker is that you've got this containerization, but you've still only got a single operating system, and it reduces the amount of disk space, it reduces the amount of computer resources, but it also simplifies management, and it makes the cybersecurity between the different components a lot better. So using Docker, we have multiple containers containing the different solutions and different applications. They do talk to each other, but they are also isolated from the outside using built-in firewalls and segregation. And it also means that if there are any upgrades, you could potentially upgrade an individual container without having to upgrade every single container in the operating system all at the same time. So there's a lot of benefits in using Docker for managing the containers. It's often transparent from the user that we're using Docker, but it does give us additional cybersecurity protections as well as making maintenance easier. Now, Linux has a lot of command line tools for managing the operating system, but to make it more straightforward, we also include Cockpit. So Cockpit is a web configuration tool that allows you to manage the Linux operating system, and it also gives you some limited Docker management as well. But we also supply Portainer, that's not on this slide, but Portainer gives you additional management tools for Docker. But Cockpit is ideal to see what your memory utilization is, your network utilization. You can see what packages are installed. So it's a very good solution for being able to determine what's going on. And it also gives you upgrade capabilities, and it gives you file access. And it also gives you the option of running a terminal easily as well within Cockpit using a web interface, rather than have to go to Telnet or SSH or some other solution. So along the bottom, that's our application management tools. And these are the things that support the other applications then that actually do whatever it is you require for your solution. So starting off, the main tool that most people will use is Node-RED. So Node-RED is our preferred aggregation solution, and you can do lots of things within Node-RED. So you can do things like create flow-based and node-based applications, which can do things like reading data, performing calculations on data, storing the data, writing the data to another application, and that includes functions like Modbus RTU, Modbus TCP, OPCUA, MQTT, database read and writes, file read and writes, even the ability to scrape other web pages from an external application. So Node-RED gives us all those capabilities to perform whatever it is you need to do. But the key point is it's more of a graphical user interface rather than having to write low-level code. Now, if you want to write low-level code, you can. We do include a Docker running Jupyter and Python, so you can create Python applications. You could also create your own container if you want to, or you could run on the base operating system as well, but a container would make more sense. And that allows you to write whatever application it is you want using whatever your preferred code is. So Java, C, C++, or any other sort of language that you like. We also support a container for TensorFlow. So TensorFlow is a machine learning solution, and potentially you could include other alternative machine learning and analytic type applications there as well. So lots of possibilities to develop your application, ranging from nice, easy to use graphical user interface applications all the way down to complex low-level compiled code. Many applications are going to require persistence of data, either for calculations themselves or because users will want to see historical information as well as current information. So our preferred database now is Timescale. Timescale was actually recently renamed as Tiger Data, but the idea of Timescale, it gives you a time series database, but it also is based on Postgres, and Postgres can be used for SQL data. So, for example, alarms and events. So Timescale is a single database that gives you very high performance for all types of data. But we've also got a couple of other databases in there which are more for legacy purposes now, because they were what we used when we first introduced PACEdge. We've got InfluxDB, which is a high performance time series database, although that's now beaten a bit in terms of performance by Timescale. And we've also got MariaDB, which is a fork of MySQL, and that's a standard SQL database or SQL database, and that gives you capabilities of doing alarms and events and other general not time series data. So the key point there is, if you're reading a real-time value, often you want to read that every second or every few hundred milliseconds, and for that sort of data, that's time series data, and you need to optimize your data to manage that time series data. But if you've got other events that occur on a random basis, maybe it's when someone downloads a set point, maybe it's when there's a start or stop of some equipment, that might not happen on the time series effect. So what would happen there is that's where you would use a SQL database, an SQL database, just to record that as an event. And also, of course, alarms don't occur frequently, and regularly, or at least you hope they wouldn't. So again, that's where a standard SQL database would be preferred. But as I mentioned there, today, timescale based on Postgres, that satisfies both those requirements and gives you best performance. So that's the one that we expect you to use going forward. Now, that database, those are local on your PACEdge machine. You could also send data to a remote database, and Node-RED can do that using MQTT or OPCUA or even a direct database write. Another option would be to use one of these databases with a stored procedure or a script, and you could store data locally and then maybe do some sort of data aggregation and then send the aggregated values to a cloud-based database. Those databases locally could also be used for store and forward. In case there's a connectivity issue or the cloud-based database is down, you can store that data locally to make sure you don't lose any data. And of course, as well as storing data, your Node-RED application, your Python application, or your TensorFlow application, that could also read data from that database if you've got an algorithm or analytics that need historical data. Now, you may want to do local visualization. So you may want a local dashboard, you may want to be able to display some KPIs. Node-RED supports that, but we also include Grafana, which is a more powerful dashboard solution for trending and dashboards and KPIs. Now, all of these applications are web-based, so the idea of Grafana is, it gives you the ability to go into the system, look at a web page, and then see the KPIs and the performance of your machine or process very easily. And those dashboards can be very, very sophisticated if required. For people that want more of an OT type solution, more of a traditional HMI SCADA, then that's where Movicon Web HMI comes in. So Movicon Web HMI is an optional extra, but this gives you the ability to create more visualization in terms of a standard HMI SCADA or operator interface. So you can draw pictures of the machine, you can animate those pictures based on real time and the historical data. And what you can also do with Web HMI as well, you can quite easily create set point actions. So a local operator could write data back to the PLC or the controlling device to perform control actions. Now, Grafana can do that to some extent, but it's probably easier if you're going to do a lot of control than to use Web HMI. And in terms of connectivity, I mentioned some of the connectivity we've got. OPCUA would be our preferred protocol. We do support MQTT as well. There is a built-in MQTT server or broker based on Mosquito, but you could also use an external MQTT broker or server as well. And the other thing that we have as an option then is Connext. So Connext is our own OPCUA based IO server based on Movicon, and this gives you a wide range of proprietary PLC drivers as well as these open drivers like OPCUA and Modbus TCP. So if there's a particular PLC you want to talk to and it's not an Emerson PLC, then Connext will probably cover you with that driver and make it easy to connect to those PLCs. And then once the data comes into Connext, you use the OPCUA server side of Connext, and then you can either store the data directly, or you could use Node-RED to maybe do some data aggregation or some pre-calculation on that data, and then Node-RED could be used to store the data into your database or do whatever else you require. So there's lots of different options there, and this is where it gets interesting because this opens up multiple possibilities for how you implement your solution. And what I've seen in practice is people often start with a pilot project, and then the pilot project might have several phases. So you'll have a minimum viable project where you have the minimum amount of equipment and configuration you need. And then what you'll do is you'll see how that can be developed and does it meet the scalability for your requirements. And it may be that you decide to pivot and scrap what you started with and do it a different way. And this will depend on how much is the project going to grow, how much data do you need, what sort of throughput is there. So there are lots of possibilities there to be able to do your application solutions in several different ways. And then, as I say, with a pilot project, start with one mechanism, see if it works, but then you could always rewrite the application later if you need to. But it does mean you also need some flexibility, because it could be that what you've done initially might be perfectly adequate, but maybe it doesn't scale as you need to, and you might want to rewrite your application later. Anyway, the point of these is Emerson has chosen these as well-known standard tools for building applications, and then we've also done some additional configuration around this to make sure that they are all as secure as they can be. So we've got this cyber security configuration as well. So it's a very good solution in terms of both the hardware and the software, being able to do pretty much whatever you want and also in a very secure way. So it is possible you'll do a lot of the work in Connext, particularly if you're looking for an OT type solution or you have a proprietary PLC protocol. But most of the applications I've worked on, we've spent most of our time in Node-RED. Now the great thing about Node-RED, this allows you to program without programming. So what you have is you have like a flowchart based system which is based on nodes. So nodes are individual function blocks and they are connected together to form flows. So within Node-RED, we've got the capability to capture data from PLCs and other devices. As I mentioned, OPCUA and Modbus TCP are built in, but you can also import other packages, and there are lots of packages available for Node-RED, and they allow you then to do lots of different types of communication. As I mentioned, you've also got the option to use Connext to bring data in and then have it available via OPCUA. But the key point is you're capturing data from your PLCs or whatever your device is. You can then pre-process that data. So maybe you want to average it, maybe you want to eliminate spurious values, maybe you want to just perform functions on parts of the data. So you've got function blocks where you can perform pre-processing. And then a typical application involves sending that data to either a local database or maybe it's a separate database, either in an on-prem or cloud-based database. And we can do that using SQL, using direct commands, direct writes, or you could use MQTT, or of course you could also use OPCUA depending on what the database supports. Now the key benefit in Node-RED, and I'll show you some examples later, gives you a huge reduction in application development time over writing, say, Python code or code in other applications. It is event driven and it has excellent performance. And what we've benchmarked it at using some of our older platforms, so we would expect better performance using our newer next generation IPC range, but we've benchmarked it at being able to handle over 2,000 items per second. And one of my clients has mentioned that they can get up to 20,000 items per second. So very good performance. It is taught in universities and colleges, and there's a wide range of built-in nodes and a huge range of third-party add-in packages. And from a configuration point of view, it's browser based. So you don't have to go in and write lots of local code or do configuration. You just fire up your web browser, which connects to your PACEdge server, and that allows you then to develop the flows on that PACEdge device directly. But it also has capabilities to import and export flows and nodes as well. So if you want to do backups, you can save things to a JSON or other file, and you can have a backup to make it easy to be able to restore your applications. Now there's another benefit of Node-RED as well. It is open source. So if you wanted to do development and you don't have a PACEdge device, you can actually download and install Node-RED on your own computer. And you can start developing nodes and performing configuration and testing and fault finding and development. And you can do all that even without a PACEdge device. Of course, you might not have all the security and other functions that PACEdge gives you, but it does allow you to get started very quickly. And also, because it's open source, there's a wide range of resources out there. So the Node-RED website itself, that has lots of training resources. And also there are lots of other people who can provide support, as well as Emerson and as well as the Node-RED. There are lots of people supporting these open source applications. So Node-RED is probably where you will spend a lot of your time inside PACEdge. And that's where we expect most people to do the majority of their development. The other area where people might be doing a lot of work is in the dashboards and reports. So this is why we've included Grafana. I mean, you could use Node-RED. Node-RED does have a dashboard capability, and it might be for simple applications you stick to using Node-RED. But Grafana has the option for more powerful, attractive reports and dashboards, and it gives you the ability to get any data, locally or remote, SQL, OPCUA and other forms, and you can get that data and you can dashboard that and observe it. Again, offers a huge reduction in application development time. So what you do is you create connections and then you perform queries on those connections, and then those connections can then be used to drive the widgets which allow you to display the data. So there's a wide range of chart types, there's lots of KPI displays, and it makes it very easy to build up nice attractive graphics, but very quickly. You know, a huge reduction in application development time, because you're not having to do this through coding. It's all developed using built-in widgets. Again, this is taught in universities and colleges, so lots of knowledge of it out there. Again, it's browser based, so you point your browser to your PACEdge device and you can display the charts there. There's also a cloud-based option, so it is possible to send your data into a cloud and use a cloud-based version of Grafana. And the benefit of that is, if you've got multiple PACEdge devices, then using the cloud-based version of Grafana, you could correlate all of that data from multiple PACEdge devices into a single set of dashboards and trends. So it's very good for distributed type applications. Again, it's open source. Yeah, you can download this and run this on your computer, or you can use the cloud-based option, and there's lots of resources available to help you understand how to create your dashboards, and lots of people out there who have familiarity with this as well. So a very good open source solution, and again, it's all about making PACEdge easy to use and allowing you to get quick results. Now, I mentioned databases. Yeah, we've got three main databases. MariaDB is intended more for alarms and events. MariaDB is a fork of MySQL, and it's optimized for these embedded sorts of applications. So MariaDB would be ideal as a standard SQL type database to store data, either for store and forward applications, or maybe because you want to put that in a dashboard or a trend, or maybe because you just need that data inside your analytic calculation. We also have InfluxDB. InfluxDB is preferred for time series data. So where you have a process where you want to monitor items regularly on a timed basis, that's where time series data comes in, and InfluxDB offers better performance than a standard database. But as mentioned, yeah, they're both now replaced by Timescale DB, which is now called Tiger Data. And what Timescale or Tiger Data is, it's an addition to Postgres. So Postgres is the underlying SQL database, but then Timescale gives you the add-ins to support this time series data. So the benefit now is we can have a single database for both alarms and events and time series data. And it also, because of the way it's developed, it offers better performance than MariaDB or InfluxDB. So for future applications, I definitely recommend using Timescale or Tiger Data. And we keep MariaDB and InfluxDB for legacy purposes, but new applications should probably use Timescale. Again, all of these are open source, and if you want to, you can download them to your local computer and experiment with them. You don't need a PACEdge device. And again, because they're open source, there's lots of resources out there to provide training and support, and there's also lots of utilities to enable you to understand and monitor and configure these databases. And we do include some support inside PACEdge, but often the data goes in and then you don't need to worry about it. There might need to be some management over time to stop the database getting too big, and that's where maybe some management comes in. But generally the databases in PACEdge don't need much management. Emerson's Movicon software can add additional capabilities to PACEdge. Now, Movicon isn't always included. Depending on the hardware, you either have to buy a different version of the hardware to include Movicon software, or it might be an optional add-on part number to add the Movicon components. So the two Movicon packages that add additional capabilities to PACEdge include Connext and WebHMI. It's important to notice that if you have WebHMI, WebHMI includes everything that Connext has, and Connext is the driver package, and then WebHMI includes that driver package along with the web-based HMI SCADA visualization tool. Now, I've got separate slide decks to cover Connext and WebHMI, but Connext covers lots of third-party PLC type protocols and proprietary PLC protocols, so it allows you to connect easily to any PLC that's out there using either serial or Ethernet networks. Now with Connext, once you've connected, The idea is you build up your list of I/O tags in a development computer, you deploy that Connect driver pack to the PACEdge unit, and then what Connect does is it goes and collects those device I/O tag values, and then they're available via OPCUA to be able to read into another application. Connect also has capabilities to store directly to a database, and also there's another thing that Connect has, which is a machine-to-machine type capability. So you might find that Connect can make it considerably easier to develop some functions compared to developing a flow in Node-RED. So for example, with that machine-to-machine capability, what Connect can do there is you can configure an I/O tag that's associated with 2 different PLC drivers and 2 different PLC devices. So they can even be different types of PLC. So for example, you could connect an Emerson PLC to a third-party PLC. And the way that works is you configure your I/O tag, and then within the I/O tag, you define 2 I/O addresses for that single I/O tag. And what Movicon does when Connect is running, it reads both of the devices using the 2 addresses, and if the value changes, then it will write that value change to the other I/O address. So that gives you a very good machine-to-machine gateway capability with very simple configuration using an OT type capability and without any scripting or any special configuration other than what you would normally do in Connect. So it's a really nice built-in feature if you need a machine-to-machine gateway. And that can work in multiple directions. If you've got machine-to-machine gateway between 2 PLCs or 2 other devices, but also then that includes the OPCUA capability to be able to retrieve that data by a 3rd device using the Connect to OPCUA server capability. So again, it gives you more flexibility and ways of developing applications. And it also allows you to simplify some things which might be quite a bit harder if you were doing Node-RED. For example, to do that in Node-RED, you'd need to read the device, you'd also need to write separately using the OPCUA server nodes. And then to get bidirectional communications, you'd need to read again. So you'd have quite a complicated set of nodes and flows to do that inside Node-RED, where Connect makes that very simple. So what WebHMI does is it adds all of that Connect driver capability and adds on a web-based HMI SCADA with visualization. So this allows you to do things like real-time monitoring, also performing set points. And again, WebHMI has some other functionality that might be easier than using other packages. So for example, it has recipe capability, it has a reporting capability, and this allows you to do some things using an IT focused type approach, which might be easier than trying to develop that independently using the IT functions. It's also a matter of choice. If you've already got that Movicon capability and you use Movicon in other areas, then it might be easier to develop in Movicon using WebHMI rather than have to think about how you would implement that using PACEdge. On the other hand, if you did have a pure IT focus, then maybe you wouldn't want to use Movicon, in which case you could purchase a device that just has the standard PACEdge functionality without Movicon. So it's just a way of adding flexibility and giving you additional functionality using our Movicon capabilities. Now you might argue that PACEdge is just a collection of open source components. And you might say, well, I will go out and buy my own industrial device and I will download and install all of the PACEdge components and run them separately. And to some extent that's true. You could do that. There's nothing to stop you choosing the best of breed components along with Movicon if you need it and creating your own applications. And we can certainly support that using our rugged industrial PC range. However, that misses out on some of the extra capabilities that we've added. So one of the key points about PACEdge is that we manage all the apps inside containers for simplification and ease of deployment, and also for cybersecurity purposes. So we close down network points, we lock down other things that aren't used, and that gives you very good cybersecurity out of the box without you having to configure that yourself. So although they are open source components, if you do it yourself, you've got that added complexity of choosing the components in the first place and then making sure that they are secure. What we do inside the system is there is networking communication between the containers, and there is an ability to communicate to outside applications, but there's a lot more security around that than if you again did that yourself. We also support the mapping of data volumes, and they're managed by the host operating system. So again, if you were going to configure this as containers, that would be a lot more work for you to do that. And if you didn't configure it as containers, if you just installed all the software, then there would be a lot more work to make sure that all the applications work with each other in terms of the version management and any other interoperability aspects. So again, using containers makes that a lot more straightforward, but it also needs management, and that's management what we do for you and provide that out of the box. So there is a big time saving in terms of using PACEdge compared to doing it yourself. Other things we give you remote access. There's a variety of VPNs which are included, so including OpenVPN and some others. So if you do want remote access, that is included. And also we provide that group management tool, again, which allows you to deploy multiple units and update together from a central location. So there's a lot of management tools built in there, which make it a lot easier to manage Node-RED and manage all the other applications compared to doing it yourself. Another aspect is we've developed PACEdge across multiple different platforms. So we have this running on ARM, we have it on AMD and Intel based systems. AMD and Intel, of course, are probably interchangeable, so that's less of an issue, but having all of the right code installed and all of the packages and dependencies installed for both ARM and x86, x64 compatibility, again, that's extra work you would have to do if you were doing this yourself. And as I mentioned, everything is version managed. Yeah, we provide the correct versions of all the applications which work with each other. So we're doing the extra work to make sure that all the components are interoperable and that they're all validated together. And what happens as well is Emerson maintains those packages. So as there is a new version of PACEdge, we automatically update all of the containers that are required. We provide updates to the underlying operating system, and we manage all of those updates for you. Again, that's something you might be able to do quite easily if you just had, one node, but as soon as you start expanding up to multiple nodes, then it becomes a much bigger management task, and that's where Emerson, along with the group management or the independent updates, makes it a lot easier for you. So PACEdge is much more than a collection of open source components. They are open source, that's true, but we do a lot of extra work to simplify the management and the deployment and improve the cybersecurity and improve the remote access that PACEdge provides. The other thing that Emerson does, which I consider unique, is to provide our edge controller. So it's perfectly possible to go out and buy a PLC, buy a separate PACEdge device, and have them communicate together using a relevant protocol such as OPU, CUA or Modbus TCP. But that requires two devices, it requires some networking, it requires some potential cybersecurity configuration, and it's two boxes that use more panel space. You've got to wire up separate power supplies. So our approach with the edge controller is to combine deterministic and non-deterministic control in one box. So what we do is we take a CPU with 4 cores and we run a hypervisor to allow us to split those 4 cores into 2 independent 2-core computers. So it's still running inside the same box, but by having 2 2-core computers, we can run the PACSystems runtime on one of the 2 cores. And with the PACSystems runtime, this gives you all of the capabilities of our other PACSystems PLCs in terms of programming. So it's the same PAC Machine Edition software across the range. It's that same capability to have the documentation in the controller. This runs your IEC 61131 Part 3 control languages like ladder and structured text and function block diagram. It gives you all of the interfaces via Profinet to your I/O. It gives you high-speed control down to 1 millisecond response times. So very good for your PLC and your real-time control functions. And then on the other 2 cores, we run PACEdge. So we've got 2 cores to run the Linux applications that we've seen on previous slides. Now, depending which version of PACEdge you buy or the edge controller you buy, we've got the CPE 400, which includes Connext. So that gives you your protocol gateway capability. And we've also got the CPL 410, which includes WebHMI. Remember, WebHMI includes all the Connext capabilities, but that gives you a proposition of a PLC with a built-in web-based HMI SCADA. With PACEdge, of course, you can also do all of the other functions that we mentioned. You've got data processing and analytics, you can do the visualization dashboards, you've got those databases for data logging and recording, and it enables that remote monitoring and diagnostics using standard tools. Instead of having to go in using Pack Machine Edition, you can make those tools useful for a less technical oriented person, and you can have it more machine focused rather than PLC focused. Remember, PACEdge includes VPNs as well, so you can make that remote access very secure using one of the included VPNs. So this gives you all the benefits of PACEdge and all the benefits of a PACSystems PLC, but all in a single box. It's integrated via an internal virtual network channel, so you don't need any external wiring. It's a single 24-volt power supply. It's a single compact device, about 50 millimeters wide by a couple of hundred millimeters high, and it gives you a very compact and secure package combining both control and also the PACEdge applications. So here's an overview of the PACEdge hardware. We start off with the micro IPC, the IPC 2010, which is based on an ARM A53 CPU. So this is running Linux. It's very good for machine level analytics and edge connectivity applications, particularly if you've got a small to medium sized gateway or you want a low cost device for up to a few hundred data items. With the A53 CPUs, this has got a benchmark between 200 and 250, which isn't very much, but it's perfectly adequate for, again, these data gateway and the sort of data collection type applications. Potentially it could run analytics as well, but it would depend on how sophisticated and complex your analytics model is as to whether this would be capable. So we've got 2 or 4 gigabytes of RAM, depending on the dual or quad core CPU. We've got 64 gigabytes of storage using an SSD. There is also an optional micro SD card in the micro SD slot if you wanted to expand memory. With this one, we've got 2 gigabit Ethernet ports. So again, as a gateway, you could use one port to your controller or to your process, and the other port could be going up to your high-level gateway to the internet or your WAN or whatever it is you're using. Now, it has got an RS-232 port, so you could use that to communicate with lower-level devices using serial protocols. Usually it will run headless, but there is an option of connecting a DisplayPort cable using a USB-C type connector, so you could plug in a local monitor, and with the USB ports you could plug in a keyboard and mouse. So you have got the capability of using this potentially as a local HMI SCADA server and client, but we would expect that most people will be running a web-based browser on another device in order to be able to communicate with this. It's relatively rugged, -25 to +65 degrees C operation, and it's Ubuntu Linux, and there are effectively 6 part numbers. So there's the base part numbers with just PACEdge in dual or quad core. There's a version that includes Connext, again dual or quad core, and then there's the version that includes WebHMI. Remember, WebHMI includes all of the Connext drivers. So again, that's that version with WebHMI in a dual or quad core version. Now, if you need more performance, we jump up to the next generation IPC. With this one, we've got Intel 13th generation CPUs. So these are Windows capable, but we're actually running them in Linux mode. So it means that you've actually got a lot more performance, because with Linux, you don't have that heavy graphical user interface load that Windows needs. So Linux gives us a lot of extra overhead in terms of performance, but these give you much greater performance. Yeah, we go, instead of 250 as your benchmark, we're now starting at around the 8,000 level. So a huge jump. Yeah, that's about 40 times the performance for the entry-level IPC 6010 compared to the IPC 2010. So benchmark is very good. There's a choice of different CPUs up to 5 gigahertz and multiple cores. We've got 8 to up to 64 gigabytes of RAM. We've got SSDs from 128 gigabytes up to 4 terabytes for very large amounts of storage. Again, there's a micro SD slot. We've got 5 Ethernet ports, and this time they're 2.5 gigabit Ethernet ports. We've got multiple USB ports. We've got multiple RS-232 and 48542 ports. And there is an option with this one. Again, I would say normally I would expect these to be used headless, but there is an option to connect 1 to 4 monitors using the combination of the USB ports, which are Thunderbolt array enabled, the DisplayPort capability, and also with DisplayPort daisy chaining. So this gives you much more advanced capabilities if you did want to connect a local monitor and do more advanced functions. Now, although this is significantly more powerful than the IPC 2010, it's not hugely more costly. You can get an IPC 6010 for around twice the price of an IPC 2010, maybe a little bit more depending on exactly which model you choose. But what I would say here is, this does open up the opportunity that for development purposes, you'd probably start with an IPC 6010, determine what you need in terms of functionality, and then either continue with an IPC 6010, or possibly you might find that depending on the CPU utilization and how much data you've got and how much storage you need and how much memory you're using, then that might enable that your rollout could actually use the IPC 2010. But certainly the IPC 6010 is very cost effective. And of course the cost does go up with the higher level models that give you significantly more performance. The other thing the IPC 6010 and above give you that the IPC 2010 doesn't is built-in RS 485, whereas if you need 485 with an IPC 2010 you need an external converter. You also get PCIe expansion. You've got the option of 1 to 4 slots depending on the model. And the benefit of that is if you've got some particular third-party interface that needs a PCIe module, then you've got that capability with the IPC 6010 and above. As standard, the IPC 6010 Next Gen IPC range covers 0 to 60 degrees C, but we do have a -40 to 70 degrees C option. But again, it's got the same base package. It's Ubuntu Linux with PACEdge, and then there are optional add-ons to add on Connect or WebHMI. And then finally here you've got the PACSystems Edge controller. This is that combined PLC CPU and Edge IPC. So it's an AMD quad-core SoC CPU, that's system on chip. It's running at 1.2 gigahertz, and as I mentioned, we've hypervised that. So 2 cores runs the PAC engine, which is the PACSystems engine for your IEC 61131 Part 3 languages. And then the other 2 cores run PACEdge. So in terms of performance, it's a bit more powerful than the IPC 2010, mainly because the G series CPU is more powerful than an ARM A53, but it's not much more. The benchmark would be about the same or maybe twice as much. It's quite limited in terms of its RAM and its memory size, but it's enough because it's running Linux, remember, which doesn't need that big overhead of Windows. It's enough to perform a quite powerful data gateway system, or it's even powerful enough to run a local WebHMI as long as your web browser is running on a separate computer. And now it's a bit limited in terms of its connections, but you have, of course, you've got your PLC CPU, which offers a lot more connectivity options as well. So although the PACEdge engine only has 1 gigabit Ethernet port, you could potentially expand that by using the PLC, or of course you could add one of our switches. On the USB side, there's 1 USB port. There's no local DisplayPort option, but if you wanted to do additional communications, we do have that via the PLC CPU and all the serial comms and Profibus and DeviceNet and other types of communications that the PLC can support. So we imagine that this will be used as a headless device, and you will always connect to a web browser, hence that's why there's no DisplayPort. We might be looking at upgrading the PACSystems Edge controller in future, but generally, as I say, it gives you a combined PLC with local analytics and local gateway capability, and it covers all of the standard functions you need. And a nice feature about the Edge controller is that it has -40 to +70 operation as standard, so very rugged. And again, through the CPU, you've got lots of different options, as well as running what you would do inside the PACEdge engine. So as standard, you've got the CPE 400, which is PACEdge with Connect, and then you've got the CPL 410, which is PACEdge with WebHMI, which includes all of those Connect capabilities. And effectively, you get PACEdge for free. So you might not be using that now, But this also gives you an upgrade capability in future. If you install an edge controller now, you might not be using PACEdge now, but in future you would be able to use that for remote diagnostics capabilities, even if you don't need it right from day one. Another nice thing about the edge controller as well, as a CPU, it's got built-in redundancy support. So for the cost of a spare, you can implement a second CPU and you get redundancy of your PLC operations, and that also gives you some fault tolerance on your PACEdge side. So with PACEdge, they're not synchronized, but you would have two PACEdge stacks running side by side. So that does give you some good redundancy support for critical applications. A big challenge for edge type applications is maintaining all of the devices. It's easy if you've got one or two, but as you get more and more, it becomes harder and harder to actually keep all of those separate devices updated. So for this, we've introduced the concept of the PACEdge Group Manager. And what the Group Manager is, it's a separate PACEdge device that includes the capability to send new configurations to other PACEdge devices. So it's based on PACEdge, and then it has the additional capabilities based on Ansible. And in PACEdge 2, we use a command line interface, but we are planning a graphical user interface with the next version of PACEdge coming soon. Now, what we can do with the Group Manager is you buy that as an appliance, as a device, rather than having to install any software. So that makes it easier from an implementation point of view. And then within that configuration that you perform, you can update the Linux operating system, you can update PACEdge applications and containers, you can update Node-RED flows. It also performs functions such as diagnostic monitoring. You can use it for system recovery. You can use it to update system security, and you can use it to distribute any other files in case you've developed your own applications or you've done your own configuration on top of our PACEdge applications. So it gives you all the capabilities you need to manage multiple remote devices very easily. Of course, you would need a connection between the devices, but again, PACEdge includes VPN capabilities. So as long as you've got that remote connection, you'd be able to configure that very easily and be able to manage multiple devices. So this is a really good way of solving that perennial problem of managing large amounts of remote devices without having to go to each device individually and update it separately. For more comprehensive utilities and management, we do have additional capabilities to be able to manage PACEdge. So we've got Cockpit, which gives you Linux operating system management. Very good to enable understanding of what's going on inside the box. So things like CPU utilization, disk utilization. Also allows you to look at the condition and performance of some of the individual containers. It also has a command line interface to allow you to get to a terminal, and it's all web-based, so very straightforward to allow you to manage the Linux operating system remotely without having to plug in a local keyboard and display. Cockpit is included by default, and that's your default management utility. It can also be used for performing updates. It does support file transfer as well, so a really good useful tool. Obviously, if you had lots of PACEdge devices, you're probably better off using the Group Manager. But for individual management and development, then Cockpit is your go-to tool for understanding what's going on. We also support Portainer. Portainer is included for Docker container management. And while many container management functions can be performed with Cockpit, Portainer gives you some additional capabilities. And then we have a variety of database utilities as well to manage those databases. So there's one for the MariaDB, there's one for the Tiger data, and there's one for InfluxDB. So that allows you to understand what is the performance of those databases. It allows you to understand what's inside the databases. It potentially allows you to, clean and update those databases. And it also performs other capabilities as well for all of the database management that you might need. Now, for additional cybersecurity protection, PACEdge also includes security certificates, and we include management services to be able to configure and control those certificates as well. So the reason for using certificates in PACEdge is effectively to encrypt communications. So that means that any data going outside of a box and over a network is encrypted, and without these certificates, no one else would be able to understand what's inside those messages. So it provides encrypted communications, it provides security of those communications, it prevents hacking, and it also prevents man-in-the-middle attacks. So a man-in-the-middle attack is where you have an intermediate device, and in that intermediate device, people might take the packets and then modify them and then forward them between the end devices. So that man in the middle is very difficult to prevent using unsecured communications. But as soon as you have certificates, those man in the middle attacks are effectively prevented. And it's also used as well, certificates can also be used for authentication to ensure that the remote device is indeed a PACEdge device. So encrypting communications is part of it, but we're also signing and ensuring that the devices are who they purport to be. So out of the factory, as long as you've got PACEdge 2.3 or above, they come with a pre-installed PACEdge certificate. And what you can do is you can add that PACEdge certificate to the browser's trusted list, and then all PACEdge device certificates are deemed as trusted. So it's a manual function you need to do to actually update the certificate. But that's the same as going to any web page. Normally that certificate management is handled automatically, but it makes sure that you've got that trusted communications. And in addition then, to have additional certificate management services, these are available through Cockpit, and you've got the capability to upload and download certificates. You can also create your own certificates as well, and you can also issue certificates for other devices. And this supports uploading certificates for things like OPCUA, for example, to the Movicon container, so you can have individual certificates for the underlying components as well as for the overall PACEdge device. So there's a lot of certificate management in there, and the whole idea of certificates, it's all part of public key infrastructure, and this is what the modern internet uses to provide secure communications. Let's take a look at some Node-RED examples to see what an application might look like in practice. So here's a screenshot showing the flows that you would create for MQTT protocol. So MQTT is a nice IoT protocol. It doesn't have much context around the data, but it's very good for sending value pairs to a remote device. So for example, you might have a timestamp and a value ID and the value, and that could be your MQTT message. So it's a very small message and very easy to send using what's called a broker. A broker is also a server. So the idea is you have your devices that send data to these brokers, and then multiple devices can connect to that broker, and then provided they've got the correct security configuration, they can update to get the values out of that broker or send additional values in there. So it's a very nice sort of peer-to-peer type communications, and it's supported by a lot of cloud-based databases, and it's also a nice simple IoT protocol using MQTT. So in this case, what we have here is we have a flow, and what we have is the inject node. So the inject node is, in this case, it's configured manually, but that could also be configured to work on a timed basis or an event basis. But what we do is we use the inject node, which is at the top left there, and that sends a value via that link to the MQTT out node. So that's that top sort of pinky purple node there next to the inject node at the top left. What the MQTT out node does is it sends data from the input node to a private or a public MQTT broker. So there are public MQTT brokers in the cloud, or it might be you use your own private broker. And if you want to, we include our own private broker inside PACEdge as an option. So you could use your internal broker, or you could send data out to the cloud using a public broker or someone else's private broker. Now inside the MQTT out node, there are properties that define the server's details. So that includes things like the network address, which would typically be an address on the internet. It includes things like the port. It includes things like the security of the protocol. And it includes all the other aspects that you need in order to be able to talk to that server. So in this example, we also have an MQTT in node, which is the one that's underneath the MQTT out node, and this reads data back from that same MQTT broker. And then the final node there, the green node, that's used for debugging, and also it can be used to pass that value to another process inside your flows. So you might write data concerning one issue, you might read data concerning another issue, and then using that data you might pass that to a different function to perform some action, maybe even potentially writing it back to the PLC. And then we've also got OPCUA client and server, and they're very similar. So here's an example of OPCUA. Again, we've got that inject node on the left. In this case, it's operating on a timed basis, and we're just injecting a timestamp value, but equally that could be some other value. We then do an OPCUA read, so that's the node that's in the middle. And then again, we've got that output there for debugging purposes, or that could also represent some other application. So what happens is inside the read node, this is where we configure all of the OPCUA settings. So we have the endpoint, we have any certificates, we have any sort of naming, any other security. And typically with OPCUA, you're using the OPC.TCP protocol. So the way that works is you then need the IP address and port number of your remote device. And then once you've deployed this, that would automatically send the data from the inject node to the OPCUA device. So very straightforward to use. And again, with that message payload output device there, you can see on the right hand at the bottom of the screen, this is the output you get from your OPCUA message. Now the key difference between OPCUA and MQTT is that OPCUA includes a lot more context around the information. So you have a node space, you have the actual variable name, you have quality values, and there's quite a bit more potentially in there. It does mean that OPCUA uses a bit more network traffic, but that's normally not that big an issue. But OPCUA is normally preferred for PLC type applications. And the other thing about OPCUA is, with that timestamp, it means that you've got a lot of built-in support for things that with MQTT, you'd have to add that separately. So OPCUA is ideal for PLC type data and ideal for data that's transferred on a time basis. MQTT is also very good, but more for generalized data, but it would really depend on what your remote device uses. So I would recommend OPCUA would be your preferred protocol to use, but MQTT might be used for a database in the cloud, perhaps like a data lake, if it didn't support OPCUA. Just a note on how we implement this, by the way. The way we implement these Node-RED flows is by using a web browser. So typically that would be on your development computer. You'd connect to your PACEdge device. You'd go to the PACEdge device's default IP address, and then that would give you a set of links which would then open up the individual applications. So there's an application for Node-RED. You'd click on that one. At each stage, you would be prompted to log in, so you have to use security. But once you've logged in, then you would see your grid enabling you to import and export flows, to create flows, to deploy flows, and do everything else you need. And also what you have here is with these nodes, you select the nodes from a menu on the left-hand side and you drag and drop them onto the screen, and then you double click on them to get to their properties. And then the debug window, that's another window that appears on the right hand side, and that allows you to see what the output is of any of these debug functions. So very straightforward to use, and again there are a lot of online resources to show you how to actually create and deploy all of these flows and use all of the nodes. So here's an example of storing data to InfluxDB. So again, we've got that inject node. We're sending data via MQTT. We've got a function in this case to calculate some of the values. And then we've got various output nodes there, including the one that's on the right, but the third from the top. That's actually our InfluxDB write node. So by using that node, you can go into that node and then you can see that you've got the options to select all of the different functions within InfluxDB. So typically that's the host computer, which might be your local computer. And in our documentation, we give you the names of all the local nodes. So that would normally be InfluxDB. That would be the local computer. Uses a default port 8086. You've got the database name. And then within that, you've then got the security for that database. and then you can optionally enable more secure communications. And then with that, that enables you to write values to that database, and also the same node can be used to read data as well. So you've got the option to read and write data, and you can read and write measurement values, you can perform more advanced queries. So there's a lot of capabilities there, but it makes it very easy, for example, to extract data from an OPCUA node and then send that data quite simply into InfluxDB, and then InfluxDB will automatically capture things like the timestamps. Although with OPCUA you've also got a timestamp with the source data, and also it covers all of the security you need, and then you would have all of that data inside your InfluxDB database, and then you could query it using whatever you need, such as Grafana, or maybe you could create a Node-RED dashboard, but Grafana can very easily access InfluxDB data by just creating a connection to the InfluxDB database and then defining what data you want to read, and then publishing that as a trend or as some sort of report or as a KPI on a gauge or dial or so on. So very easy to access the data once it's stored in. And what InfluxDB gives you is very good support for this high-speed time series data. So very good for where you're recording lots of data at a fast cycle rate, and InfluxDB can handle that for you. Here's a Modbus TCP flow. This one is particularly simple because you have different flows to read the different types of Modbus data. So in this case, we've got a read analogs node, and then that goes straight to a debug node, and you don't really need anything else. Now that's partly because Modbus itself is a simpler protocol, but also with this particular implementation, the developer has designed it so that you've got separate flows or separate nodes for the different data types. So depending on what data you're reading, then you might need to adjust the different node types to read that different types of data. But you can see, very straightforward. The read analogs node polls the Modbus TCP server or slave for data. Within the node's properties, you've got the definition of what the device is. So there's an IP address, the port, which is normally 502. There's no security because Modbus TCP doesn't have any security. There's simple stuff like timeouts and so on. Then there's the function code you're going to read. So you might need some knowledge of the actual Modbus protocol itself to understand what it is. And then you've got the address and quantity of registers you want to read. So this can read multiple registers and bring it back. And then, as usual, the output can go to a debug node, or it could go to something else, such as a function node, to be able to perform some function. But very straightforward. Now, an interesting aspect of this is it means that you could potentially use a RSTIEP module, the Modbus network adapter, and you could use that to read in discrete or analog data coming in from some other device. So this happens sometimes where you don't actually have a PLC or a device where you can read the data. You need to actually add that device yourself. Maybe the instrumentation doesn't exist at all, or maybe there is instrumentation, but it's very simple discrete or analog values, and there's not an intelligent device you can read. So what you could do in this case is install a PACSystems RSTIEP device at that location, and then this Modbus TCP flow, that could be used to read the raw data, and then you'd use the function node to do whatever preconditioning you need. So it opens up another possibility for edge applications. You can actually get data in from completely unintelligent devices, even if there's no PLC there, by combining PACEdge with that additional I/O device. Now we saw the flow for writing to InfluxDB. Here is the database application to write data into a SQL database. So in this case, we've got the left-hand side there, you've got your insert node. That goes through a function. And what we do in the function is we actually define, in this case, a SQL query. So inside that query, we've actually got some very simple JavaScript in the onMessage function. And what that does is it extracts the value from the data node, and then it inserts that into a actual SQL query. So you can see there you've got the message topic, which is insert into, and then we're just inserting into a database, and we're not using any special manipulation here, but that could be a number, it could be a timestamp, it could be a value, it could be something else. But the idea is you can create simple JavaScript and then within the JavaScript implement your own SQL query and then send that into the database. So in this case, this could be the local database. You see you've got Emerson MySQL, which is the MariaDB database, and then you've got the usual username and password and port you want to use. But it's very simple to insert the database data, but you do need to think about the SQL query. So this one's maybe a bit more complex with InfluxDB, because with InfluxDB you haven't got any SQL to worry about. You're just writing data directly to the database. With this one you have also though got more flexibility, because with that SQL command you can do more than what you could do with InfluxDB. So it's both a bit more complicated to use, but also you get a lot more flexibility. Now normally you would use Grafana for dashboards, but for simple dashboards you can also use Node-RED. So what you do within Node-RED, you've got nodes and flows that you can use, and you can use those to actually create variables and assign those to dashboards. You then create a dashboard like this one, and you can see you've got a combination of trends, charts, and you've also got gauge type, KPI indicators. So it's very easy to create a quick dashboard using Node-RED, and there's nothing wrong with doing that. But certainly if you've got a more complex and comprehensive dashboard, then I would recommend Grafana. So that's Node-RED. I'm not going to cover Grafana or too many of the other applications. I think, as I mentioned, the majority of time will be spent inside Node-RED. If you want to do more work with Grafana, then go to the Grafana website and you can have a look at their resources. And the same for Node-RED. You can go to the Node-RED website and there's a lot of training resources and sample code there that you can look at to see exactly how all these nodes and flows work. Now, Node-RED can be extended. It is possible to write your own nodes and flows. It's also possible to download other people's packages, and there are lots of things you can do. Node-RED could be used to implement open as well as custom protocols. They may or may not already exist. Certainly we've seen OPCUA and Modbus TCP are included. There is a function node which can perform calculations, and they can be quite comprehensive calculations because you have got the potential to use JavaScript to extract your data and do whatever calculation you need. And that calculation could also be combined with historical data. So you could do a SQL database query, bring back some historical data, combine that with current data, and you could do quite a complex calculation there. You've also got the capability to read and write files. So I've used Node-RED to write a CSV file. You could also read and write HTML, JSON, XML, etc. So lots of capabilities there for pure file storage. It's also possible to read external websites and scrape data. So sometimes with a website there will be an API and you can use the API directly to get the data you want. So that could be done using a HTTP request, but sometimes you want to actually read the whole website and just extract relevant data. So that's also possible as well. Node-RED can also send emails. So there's an option there to integrate with various email servers. And you can also integrate in many other ways with cloud applications. So, AWS, Azure, etc. You can integrate Node-RED with those applications using whatever sort of protocol you need. So, you can do raw HTTP, you can do things like REST APIs, you can integrate with databases using some of the flows we've already seen. You can write files and you can send files. So there's a lot of options there to allow Node-RED to be used as your primary gateway capability for PACEdge applications. So I'm going to finish off with an architecture slide. So this shows you how PACEdge might work in real terms. So regardless of whether you're using PACEdge as an edge gateway or an edge computer, or even if it's an edge controller, the actual functionality of PACEdge remains the same, and we've seen that through this slide deck. Now you've got the possibility of connecting a local client. That could be directly via Ethernet, or maybe you're using Wi-Fi, so there's a possibility of having a Wi-Fi access point. And as Emerson, we do actually provide a Wi-Fi access point as an option for PACEdge devices. You can also, with some of the CPUs, you can get Wi-Fi as a built-in option with the IPCs. Another possibility might also be to use a GSM modem. In this case, of course, it's not local anymore, but you could use that GSM modem with a fixed IP address and that way you could connect via the standard GSM cellular type network. So that local client, yeah, that could be a FIC client. It could be connected directly. You've also got the option of using DisplayPort and USB, of course, or it could be a thin client, using web technologies or other technologies. And then you've got the computer itself, and the computer, the edge computer, that supports integration with all of the field devices, IO modules and safety modules and so on. And we support a variety of protocols there. So as we've seen, Modbus TCP, OPC UA, etc. And you can just stick with that. You could just have a local device that's storing data, and maybe you just need that for compliance issues, or maybe you need it because you want to be able to diagnose machine issues later on. But if you want to, the next step would be to connect the edge computer or gateway to a cloud-based application, or maybe this is via your wide area network to your own on-prem database. But we do that using a VPN. So regardless of whether it's a wide area network, maybe the VPN already exists in that case because it might be an encrypted WAN. Maybe you're using, an open GSM network. Maybe you're using a direct internet connection. Maybe you've got an older technology like a leased line or wireless or something. But the idea is PACEdge has the built-in VPN capabilities to be able to create a secure connection to your cloud-based or your on-prem database server. And then you've got lots of options for sending data. You can send files directly. You could send data via a SQL database. You can use OPC UA, like I mentioned, REST, MQTT, or whatever mechanism makes sense for you. And then once the data's in the cloud-based data server, that could be doing whatever you want. So maybe it's a Movicon application. So you might be using a Movicon HMI SCADA as like a central server. Maybe it's a cloud-based data lake, such as Emerson's Delta V data lake. And then of course you connect your clients to that data lake, be they FIC, mobile, terminal services, RDP, or whatever clients, and they can access that data however they like. And that VPN connection, that could be two ways as well. You can also get a connection onto the internet directly, and that could be used for file scraping or data scraping, so you can get data back into the edge device that way. And as well as reading data from the field devices, you can potentially also write data to the field devices. So for example, with PACEdge, one thing you might want to do is have optimization of your process. Maybe you're looking at the weather, so you can optimize your process based on future weather patterns. Maybe you're looking at energy prices. You could optimize based on what the energy price is. Maybe you're looking at some other coordinating data. For example, maybe you've got a fleet of assets and you want to decide which asset to run or how much to run it and so on. Maybe you want to report back for vendor managed inventory purposes. Maybe you've got a remote generator and the fuel is getting low, so maybe you want to send an alert on that basis. So all of those things we talked about earlier on, they're all capable of being solved using this PACEdge architecture. And I'm just showing a single device here, but you can have multiple devices. So if you've got a fleet of assets, you're not limited to a single PACEdge computer. You can have multiple PACEdge computers, and they can all be updated and synchronized using a group manager if required. So that's PACEdge. It solves a lot of edge issues. And as I say, the key point, the key differentiator we have, it's both hardware and software. Lots of people will sell you a rugged box. Lots of people will sell you a cloud-based service, but very few people will sell you an integrated hardware and software solution with all of the embedded cybersecurity, as well as all the updates and the remote access capability. So PACEdge ticks a lot of boxes for these edge and IoT applications.